Topic 1.5, problem number 7. Okay, we want to factor this, and first we look for greatest common factors, and there are none. Then we look for LCDs to see if it was divided by anything, and we do have a denominator of 2. So the least common denominator for this will be 2. And so this tells us that someone must have taken the original problem and divided it all by 2. That's what 2 in the bottom here means. So let's find out what the original problem was. And we're going to multiply everything by 2 in order to find out what it originally was before division by 2. So multiplying this by 2 makes this 2x to the 6th power. Multiplying this by 2 gives us 14 over 2, which is 7x cubed. And multiplying this by 2 gives us 6. All right. Now, I'm going to take this trinomial here and I'm going to factor that into 2 binomials. Okay. So 2x to the 6th, let's factor that into 2x to the 3rd power times x to the 3rd power. Now we're going to have to factor the 6. Let's factor the 6 into 3 times 2. 3 times 2. So that'll give us 3x cubed here in the middle and 4x cubed here on the outside. And the signs must be the same to get a 7x cubed. So plus plus does give us the 7x cubed. So plus plus goes there. And this was the original problem before multiplication, giving us this. Okay. Number 8. Again, number 8, I look for greatest common factors. There are no GCFs. Then I look for denominators, which indicate it was divided by something, or shall I say, I'll find the least common denominator. We have a 4, 2 here, so the LCD is 4. So someone must have divided all by 4. So 4 here. Then I want to find out what it was originally by multiplying it by 4. So when I multiply this by 4, I get 12 over 4, which reduces down to 3x to the 4th. I multiply this by 4, I get 20 over 2, which reduces down to negative 10x squared. Now multiply this by 4, and it becomes a negative 8. Okay, so this is what it was originally before division by 4. Next, I'm going to factor this into 2 binomials, since this is a trinomial. 3x to the 4th can be factored into 3x squared times x squared. 8, let's factor that into 2 times 4. Let's try that. 2 times 4. So in the middle we're going to get 2x squared. Outside we're going to get 12x squared. And the signs have to be different. So the signs have to be different, and we want a negative 10x squared. So I'm going to make this positive and this negative. And this combination will give me the negative 10x squared. So positive, negative, that's positive here, negative there. So now I have a monomial times 2 binomials. But this binomial is a difference of 2 squares. That can be factored as well into 2 more binomials. So we'll have 1/4, 3x squared plus 2. And this factors in 2 binomials by simplifying this with a square root. We get x plus 2 and x minus 2. And so this polynomial originally was 1/4 times the 3 binomials here. Okay, next, number 9. Number 9, there are no greatest common factors, so no GCFs. But because of all the denominators, I noticed that there will be LCDs. Okay, so we have a 3 and a 2. The least common denominator for that is 6. So someone must have multiplied this, divided it by a 6. So let's reverse that process by multiplying everything by 6. When I multiply this by 6, I'm going to get 12 over 3, which is 4x cubed. Multiplying this by 6, I get 12 over 3, which gives us 4x squared. Multiplying this by 6, I get negative 18 over 2, which is negative 9x. And then multiplying this by 6, I get negative 18 over 2, which also is negative 9. Now, I'm going to take GCFs out in groups. The GCF for just this group right here is going to be 4. In fact, let me put a bracket here. Will be 4x squared times x plus 1. The GCF for these two will be negative 9. So we'll take out negative 9 and divide everything by negative 9. We'll get x plus 1. Now I'm going to pull all my greatest common factors out to the side here. So 1/6 is pulled out, x plus 1 is pulled out, and what remains is 4x squared from here and the negative 9. So I've just converted this into a monomial times two binomials. But this binomial is the difference of two squares. So I can factor this further into two more binomials. So this is 1/6 times x plus 1. Taking the square roots of this, I get 2x plus 3 and 2x minus 3. And so finally what I have is a monomial times three binomials as the original problem for this.